Hello, 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 everybody. Hope you guys are doing well. So continuing on our journey in um, continuing our journey in OOP. Um, Today we will try to understand uh, uh, some more concepts, and we will try to see how um okay. So today we will try to understand the need for generics, and we'll try to understand like why do we need generics, and what is the advantages of using generics, and where should we use uh, generics, and where should we not use generics, and all other trade-offs. Okay, so now generics allows us to write code that works with any data type while retaining static type safety. This means that we can use the same code with any data type, still letting the compiler find type errors. Sometimes the only essential difference between two pieces of repeated code is a data type. As we have learned, eliminating duplication is a key part of improving the maintainability of a software, right? With generics, also known as parametric polymorphism, we can eliminate such duplications without giving any static type safety. Meanwhile, without giving up the compiler's ability to discover type error at compile time instead of running the risk of getting them at runtime time. Imagine. Okay, so let's understand why do we need generics, right? Let's understand why do we need generics and what is the goal of using generics. Okay. So many languages like Java need type safety, right? Because if you have any incompatible type being mentioned here, then you will get an error, right? But the problem is with you with mentioning type everywhere is what if in some point in time you want to change that variable type. So that cannot be done, right? Once it is initialized to the specific type, you cannot change it elsewhere in the code. So this is where the problem lies, and this problem is what we overcome with generics. Now what we do is we can use the same code with any data type, still letting okay. But the advantages and of using so for example, if you're trying to subtract two numbers, and then they've already declared that variable as a string, right? If it's a generic, then what you can do is you can assign the same variable to an integer, so that the compiler will still look out for type errors, but type safety will be maintained. So this is basically the advantage of using generics, right? Now, generics are also called as parametric polymorphism. The parametric polymor polymetric sorry polymetric parametric polymorphism. Now, when you say when you say polymorphism is basically poly means many and morphism means forms. So since the generics, you can have many forms being used to them, so they are called as they are supporting polymorphism. And then why parametric, we'll see that in a later we'll see that ahead, right? Now what does it do is this helps us to eliminate static type safety, right? And it avoids code duplication, right? For example, um, basically we are going to the only difference between the two piece of okay, now sometimes the difference between a piece of code is only the type being changed, right? So why to declare another variable of a different type again and again? So remember, avoiding code repeatability is one of the key factors, right? That is going to improve our code. Now imagine, so basically, by doing parametric polymorphism, what are we achieving is we are basically achieving something called as we are avoiding code reusable. We are avoiding repeating code, right? And we are promoting code reusability. I imagine that we have gotten tired of the fact that arrays have a fixed size and we have to access. We have to create a new array every time. So let's consider one more example, right? For example, suppose if I have a fixed size array, right, and if I want to change the size of the array, now every time we want to change the size or we want to add a new member to the array, we will have to create a new array, right? This is not right, but this is not proper, right? So instead what we do is we decided to implement a class called as list, right? Basically this is what do you say, you can add an or remove an element, right? Now when we are writing the code for method that add items to list, so on similar lines, if we are writing any code, do we really need to know what type of element we are adding? So for example, yeah, so what he's trying to say is, suppose this is a list, right? It does not matter, right? Whatever you can add, you should be able to add. So that is the main advantage of using list over arrays, right? Because these are fixed size and you cannot add members to them. But then here you can add any members, it can be of any type. So what I'm doing is I'm increasing code reusability and avoiding code repetition. Now as long as the type of the item we're about to add as the same type as all the other items, that are, it doesn't matter. Yeah, so remember they have to be homogeneous, right? You cannot have a string and a number being present, right? So okay, so what he's saying is how will we design this code, right? Like how will we um it's a cumbersome process, right? Okay, so this is our array, right? So arrays are of fixed size, right? So this is a fixed size array. And now what if we create a list, right? If you create a list, so we have to write some algorithm or some code that is able to have like a flexible array being generated, right? So what first we will do is that how will the algorithm look like? So first is basically you're going to create this is the original array, right? So the moment you want to add an member to it, what you will do is you will first create an array that has the size of this array will be +1 what the size of this array was, right? And then what you will do is you will try to copy everything, and this is where the newest element will go in. And then put the element that we want to add in the end at no point. So here what he's trying to say is there was no point in time we checked the type, right? Except that all elements I mean nothing related, so there was nothing like at no point in time did we check whether the type was same or not, right? Similarly, as long as all the elements are the same type, we can safely extract them. There is no fundamental difference between the code for a list of strings and the code for a list of int or any other type. So what he's trying to say is this mechanism or this algorithm will remain the same, right? If it is a string array, if it is an integer array, uh, if I want to add a new character to a string, right, I'll have to do somewhat like this process, right? So this process is something which is independent of type, right? So because it is independent of time, we are able to apply it on all types. It works on int as well, and it works on string as well. So what it does is this, it kind of gives us a um, uh, the ability to write what do you say, the ability to write a general code irrespective of the type. Now, object-oriented languages that support parametric polymorphism, which is in many languages called as generics, have a type called list, which works along the lines of what we have described. So, in many languages in OOP which have so this is basically what he's trying to do is, this is how a dynamic array or a list will work, right? Without uh, so nowhere in this process did we check for type, right? This is what is a list, right? Now the idea is basically that our whatever we create, it will be what do you say, it will be universally polymorphic. If you are familiar with formal logic, this corresponds to the concept of universal quantification. So what we are saying is a generic type is a type that can be defined for all types. Now the instance and the static members can be defined. Okay, we can write a single implement. Yeah, so that is what is enabling. Without we can write a single. Okay, now without overloading, we define different implement with. Okay, so he's saying yeah, with generics, what you can do is you can have with generics you can have instead of having different instead of having any type specific thing, what you do is you kind of create a general algorithm, and all types or all, it can be used anywhere, right? It's like a general thing which is independent of the type. However, still at compile time, for example, if you are performing some operation, right, we are still not losing the feature of compile time checking, which will still happen, right? For example, if you try to subtract a string with an integer, and if your generic is a string, it will still give you that error. So compile time checking is not lost. We are still having that feature. Now then the bigger question is, if you know if it makes our if it increases code reusability, and if it kind of helps us a lot, then can everything be generic? Like, can we make everything generic? Because if everything is generic, then it's easy for us, right? um uh, Basically what he's trying to say is, can any type become a generic type? Can any algorithm become a generic algorithms? That is, so are we are trying to understand, can we have everything as generic? Should we make everything generic? Now no, because the answer to this is no, we cannot make everything generic, right? Because the reason is, generic algorithms, they do not, or generic type, uh, they will not take care of type, right? But some algorithms cannot be expressed without, for example, you cannot um uh yes, what is trying to say is, generic if it's an algorithm or if it's a type, it will not take into consideration what type is being used at. But in certain places, algorithms are developed in such a way that they are very type specific. That means if there is a type mismatch, or that is, while implementing those algorithm, we'll make an assumption how the underlying type would be. So hence everything and anything should not be a generic, right? For example, algorithms that deal with, or that assume, no, what I'm trying to say is, when we assume how our uh, um, algorithm is going to work, or what are the key, by making an assumption, by uh, making an assumption that the data passed will be of a specific type, uh, then we should not use generics, right? For example, let's assume arithmetic operations, right? Whenever we do arithmetic, we assume we are dealing with numbers, right? And we are not dealing with strings, right? For example, so assume arithmetic. So while using arithmetic operations, we assume that we are only dealing with numbers, right? So uh, making it generic is of no sense, right? So again, here we are taking into consideration that we'll be adding a number. Okay. Or for example, sorting. Now these are defined for some. For example, if you're trying to sort, right, you sort either alphabetically or based on values, right? So what we are taking into consideration is that underlyingly they will have either a string type or an int type. So at such places, when you are assuming the type is something and you're defining an algorithm based on that, then it's the at such places we should not use generics, right? While it is possible to write an algorithm that defines how instances of a given type are added or sorted. We cannot assume that an algorithm exists. So what he's trying to say is, what if the user passes something very random, right? I mean, if it's generic, then anything can be passed in, right? Even objects can be passed. Then how will this work? Hence, so what are trying to say is, if our code is assuming that we have that our algorithm or our algorithm uh, is developed based on making an assumption what the underlying type may be. At such places, it's at such places we do not do generics, right? However, in places where the type does not matter, in such places we can use generics. Now, so hence, okay. Now, if a code needs, so hence, if a code needs to assume something about the internal time that is not sure for all types, like that it must form an order, or that then the code is no longer parametrically, it's already not uh, polymorphism, right? You are not achieving, then why do we need to define generic? Because the goal of generic is to have that parametric polymorphism, right? But is there a way to have the cake and eat it too? Yes. So now, um is there a way to limit this generic strict to a certain type? Yes, we do. We can do that. So we do also have something called as bounded polymorphism, or also called as, you can add constraints to these parameters. So we'll see that in later sections. Okay. Now, generic types that are parameterized over types using so-called. Okay, generic. So then he's saying, what do you mean by generic? Now, generic types are those that are parameterized over types using so-called type parameters. Now, so he's defining something called as generic types, and um, okay. A generic type definition is a blueprint for creating types that are using other types. A generic type definitions are parameterized over other types. Now, generic types are defined in the same way we define non-generic types, but what we do is we kind of so generics are mentioned in an angle brackets, right? So whenever you see this angle brackets, what are we saying that this is a generic type, right? Then so can we have multiple parameters being passed over here? Yes, you can have multiple parameter or multiple types, right, being generic. So generic types are defined the same as non-generic type, but what you do is after every you kind of put in a comma. So this is called as generic type parameter. Okay, so basically what he's saying is, what if we have a function, right, and that function takes in multiple parameters. So then how do we define that like the parameters, right? So what you do is you mention how do we make all the parameters access. You type in the type here, write in the type here, and then using that you can so basically this is going to be, and then this is going to indicate the list of parameters and they will need to be separated by a comma. So basically the parameters have become multiple parameters have become a generic type. Now, generic type definition. Now, if you want to be able to store pairs of objects of arbitrary data types, then would such a type be useful? Imagine that we are building a board games, right? um Now again, so for example, when we are building a board game, now depending upon how one wants or how is what the game played is, the background color will change, right? Or the bound background what do you say view, background appearance will change. So then here is where you can use a generic, right? Now let's build a generic class for this and let's call it the pet. Now t is yeah, so what we do is we kind of mention in here and say that this type is a generic. Now by parameters in the class we make it possible to use the same class. So the concept of a pair in program is called as a tuple. But in a generic type definition, to construct an actual type you must replace the parameter. Okay, but then what he's saying is whenever you are implementing this generic, you need to actually specify what type it is, else you won't be able to work with it. So uh, although we say although we have mentioned it generic, but when we are trying to use it, the actual type must be defined. So actual type must be defined the moment we try to use this. Now constructed generic types. Now if we say pair int, then we have a constructed type by so uh, uh, okay, now what we are doing is there's something called as constructed generic types. So you can have constructed generic types. Now if we say parent, then we have created constructed a generic type by replacing the type parameter t in the generic type definition with an argument type int. If we say string, then we have constructed a generic type by replacing the type parameter with a type string, right? Since all parameters can be of any type, yes, we can of course also make pairs of cards or dice rolls. So you can have pairs as well. Now type parameter. Now usually languages have a convention to what they call the type parameters. Generally, it is started by t or some other prefix, which is just t key or t value, followed by a number t1 or something. Now, let's see. Let's see. So constructed type is basically you. It's a generic, but what we do is instead of using the type T, you indirectly mention what the type is. So this is basically a constructed generic type. Now let's study certain because even because what I'm so what the rule says is, if you have declared a generic type, whenever you are trying to use it, you will have to mention what the actual type is. So now let's study certain terminologies involved with generic, right? uh, so the first thing that we or that we study is basically called as generic type definition, right? So basically this is the that generic which hasn't been used or initialized, right? It is just written in angular brackets t, right? This is basically our generic type definition. Now then is something called as constructed then we have the type parameter, right? Basically it's a placeholder that is used to it's a placeholder, so it is um, placeholder used to represent type. So generally in it's generally given as t in many languages. The next thing that we have is something called as constructed uh, generic type. So uh, constructed generic type. So this is when instead of having generic, we have actually mentioned the types. Okay. So generic type is basically instead of instead of using so this is when we so this is when we actually mention the type that we are using. It can be int or anything. Basically the actual type that is provided, right? Making it this being usable. Now type argument, so basically whatever we provide inside the for example we say this is, so we say, so when while using we'll mention the type, right? So this is nothing but um uh, this is nothing but the type that we have mentioned, right? And while on, and it is all, this is also called as a type argument, right? So this is also called as type argument. Now generic type, this term can be used to refer either a generic type definition or a construct, so you can refer to any of them. Now define a generic, how do we create the generic class? I mean, so certain languages already uh, have them and we just need to use them. So how do we create the generic class? Okay, so now let's see with respect to Java, right? Because we are studying everything with respect to Java. So what are we going to study is how to uh, okay. Okay, so now can we define a class as generic? Yes, we can make a class as well as generic, but make sure that when we are going to use that class, you need to define the actual type, right? Because the moment we try to use it, the type of that generic has to be um what you say, the type of that generic has class or anything else has to be mentioned. For example, okay, so this is here is where he's mentioning the type. So okay, let's see. Hmm. Okay, so now there is some blueprint, some important points, right? Now it's not mandatory for us to. We can use the raw types as well. That no type being satisfied, but that will what that will do is it will bypass it, right? And at runtime, depending upon what you are assigning, so it will check the type at runtime. We don't want that compile safety feature to be lost, right? So it's basically important for us to specify the time so that we can ensure that type safety is being maintained at compile time. So we do not want to lose or play around with the type safety feature. We want that to be intact. Okay, then we said okay, how to uh, okay, so now so we said we can define a generic type. Can we have a generic class? Yes, you can define a generic class as well, because class is nothing but a type, right? So the way to define it is, remember, we don't want the compile time feature to go away. So uh, okay, let's first define the class, right? So this is our okay, so this is our let's have this. So this is our class. We say that now when we say it has a generic type, what we are meaning to say is the attributes are the of a generic type, and whenever we are going to use these attributes, this is going to go in at the time of um, so we are going to set this item, right? So the at runtime, whenever we are going to create the object, basically in bracket we are going to mention what type are we passing in. Yeah, so we don't want to bypass that compile time feature, right? So what we will do is oh, where is our main this is test, there has to be main somewhere. Where is public static void main? Okay, yeah, this is our main, right? So the way we are going to create the object here is okay, alright, this did not work, so let's go to so this is how we are going to create the object string. Now this string is basically mentioning the type, right? Because Remember, we need that compile time feature being the like we need that compile time comparison type safety feature still to work, right? Okay. Now then we can have nested types as well. So um that is one thing. So yeah. Um. Okay. So let's just I had one little thing, right? So there is a statement that we say, right? Generic types are parameterized over types. I mean, parameters are basically passed, right? For example, this constructor we would be okay. Okay, so we say that generic types are types that are parameterized over types. Parameterized means what is trying to say is so whenever you define a type, right, you're kind of mentioning that that thing in angular braces, right? So that angular braces is nothing but type of a parameter which is uh, um, which is our placeholder that can we can later replace with a real type when we use it. Hmm. Okay, so now when the so as so like when we declare a class, right? I mean, when we mention a class as a parameter, sorry, a class is a generic type T, right? So remember, um, uh, so suppose yeah, this is a class, right? So we say that our class has a generic type T. By that we mean to say is that the instance variables are generic in nature, right? Remember, there is no type mentioned. This is a generic type. The reason for this is because these generic variables are created when you have this or this class object been created, right? Or it is these instance variables that are going to get attached to this type. So hence we say that it is the attributes or the instant variables that are going to reflect the generic type. Okay, so and then in functions, because remember the whole point of so if I have a function, right? um um the way okay, so if this is my function, now remember, the what do you say, um the data that we are going to use is going to be passed in here, right? So that is going to have a type. So hence when we mention that this is a generic type function, we are saying is the parameters being passed are generic types. So for example, now this will be implemented when we call the function, right? So you will mention what type of parameters are being passed, because the yeah, it does not accept so yeah, that is what so the other question you might have is, you have local variables as well, right, inside the function. Why aren't those made generic when you have a generic type function being declared? The reason for that is whenever because whenever you define a function, right, it is the parameters that you're going to call from the function are basically going to indicate the type, right? It is going to indicate what the function will operate on, and how will it produce the result, right? So hence we don't say that the local variables are have a generic type. Instead, it's the parameters that are responsible for uh, doing the addition and other, or doing the other operations, right? So that is what is important, right? Now the main advantages is, remember, still at compile time we need to mention the type, right? So however you can what do you say, you can try to avoid them, but then um it is not a very good way, right? I mean, um, because then you lose the, if you try to avoid that type initialization or constructing the time, then what is going to happen is you're going to lose the feature of runtime checking, sorry, of compile time checking, right? And then runtime checking kicks in. So a program is already into the memory, and then you're checking for the type. That is not a very good approach to write a code or to do programming, right? Now type parameter constraints. Now what you can do is you can add constraints as well. So in, if it's a prototype, if what you do is you can add constraints in here, saying that, you kind of you are restricted to some can have a colon and have some constraints being mentioned over here, so you can do that as well. Okay, so now and in fact you can combine constraints as well. So the way to combine constraints is you can use aware, right? For example, you can use aware. For example, in Swift we have something called as aware keyword, right, where we using which you can add in constraint to the types. The next thing that we are about to study is basically something called as iterators, right? What is an iterator, and why do we need it, right? Many languages have that iterator, right? It's an iterator. So um, okay, we'll see that in in the next lecture, I guess. This is all. I think so. Let me check. Did we? This much is enough for generics. Although you have much more, but um, I guess this is more than enough to cover the basics. And later on, we'll see some when we dive deep into. We'll see some advantages of some more advantages of using generics. Yeah, that's all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.